Good morning, welcome back. We'll be discussing Chapter 2. So Chapter 2 is about basic elements of C++. So we will be probably spending hour and a half on this chapter, and then we'll move on to the hands-on exercise. In the hands-on exercise, I will actually show you some of the techniques, and all the demo files are already available on our LMS or on Canvas site. So if you cannot see some of the demo, especially for online students, I invite you to open the demo file and run while you're watching this video. All right, so our goal is to discuss the data types and along with some of the other basic building blocks, basic elements. So this chapter might overlap some of the conversation we had earlier. So some of the things we talked about, such as variables, what is a function. So the chapter begins with that kind of conversation. So let me start with the chapter. So in this chapter, so we'll talk about, let me turn on this. So starts with this concept here, computer program. And we know what the computer program is. How do you define a computer program in one statement? So computer program in one statement is? Set of instructions. That's a beautiful statement. Set of instructions. Instructions are basically, you have, just like a recipe, you have certain ingredients and you have certain steps involved. So in case of ingredients, we have data. In case of steps, those are the instructions or statements. So computer program is set of instructions. So the programming is a process of planning and creating that program. All right. So here's an example, and we did one example together last time. So this is from Chapter 2. There's an example available, and that shows the results, and it discusses various areas, especially the areas where the data is declared. So we'll talk about those variables in a lot of detail in this lecture. So how do you define a variable? What is a variable? So remember, we talked about data. Data can be processed into. So programming means you're processing the data, and you process the data into what? What do you get as an output? So data is the input. Then you have process in the middle. So you produce information. So information is processed data, and data is unprocessed information. So your goal as an information system developer is to process the data. And in order to hold on to the data, in order to, like a placeholder, you need a variable. So when you bring the data, how do you bring the data? You bring the data from a user by scanning, by reading a file or database from the web. When we bring the data, you need to hold on to the data to process it. That holding location is called a variable. So when you declare a length or width, all these are variables. So in today's lecture, something I really want you to take with you is what type of variables we are going to use in our class for the rest of the semester. And in fact, we'll get to that area, but these are the 5 variable data types we are going to use. And we are going to stick to these data types. Okay, so variable is a placeholder for your data. Also, when you have these instructions kind of compacted in one location, we call it a function. It's a smaller subprogram. We used to call them different names in the past. We call them subroutines, procedures, subprograms. In the modern object-oriented language, we call them methods. So you will hear these different terms: methods, modules, procedures, functions. In our class, we'll call them functions. So how do you define a function? Collection of statements. So you have all these set of instructions, you combine them, related instructions, you put them in a function. And the function, in a classic term, is supposed to perform one thing and one thing only. So if you have a square root function should be doing only square root. It should not be doing other things. If you have a print function should be only printing. Should not be doing other things. So function is basically set of instructions to perform one specific task. However, when we are learning, our function, such as main function, might be doing multiple things. But gradually we'll learn a skill that how we can divide another function can take the input, another function can do the process, another function can do the outputs. So then we have to follow certain rules, and those are syntax rules. What's the other word for syntax? The grammar of the language. So just like when you learn Italian or Spanish, you have to follow certain grammar rules. So each one of these languages, they have their own syntax rules. Now, some of these rules overlap in these 4 languages, C, C++, C#, and Java. For example, ending a statement with a semicolon. Not all the languages must end with a semicolon, but these 4 languages. So there are certain commonalities, and there are some differences as well. So which statements are legal or valid? Now, the syntax rules are compiler basically figures it out if it's written correctly or not. So syntax errors are easier to find. So when you run your code, as soon as you run your code, compiler is going to try to translate into machine code, and it's going to tell you there's something wrong in step number 8. There's something wrong in this particular instruction. Determine the meaning of the instructions. Those are called semantic rules. So those are more like logical rules. What exactly will happen if you execute this statement? So again, the programming languages set of rules, symbols, and special keywords. Okay. Also, we talked about this one in the first project, but you can comment out certain things. Commenting out means you want to leave some information in your code for your sake or for your team's sake, but it will not be compiled. It will not be executed. So you can leave a single line comment by // no space in between, or multiple line comments /**/. Did we do that in the first project? So yeah, so you want to do in the second and all the future projects, you want to leave the comments. You don't want to leave comments for every single line of code. You want to leave comments which are critical for your understanding or for your team's understanding. Because when you're working a large project, there are multiple people working, and also when you revisit your project, you might forget that particular instruction. There are some special symbols, and we'll be going through all of these symbols. Some symbols are called arithmetic operators. Some symbols are relational operators. Some symbols are logical operators. They have special meaning in these programming languages. For example, in the first project, we used rate multiplied by, which is this particular symbol, multiplied by hours. So that allows us to do the multiplication. All right, what are the reserved words? Reserved words. Those are the basic words which have special meaning in the language. So some of the reserved words are shown here on this page. Anybody has a paper book? At the end of the paper book or at the end of your book, you will see all the reserved words of C++ language. I think it might be, let me see if I can show you very, very quickly without wasting any time. Might be 1200 something page, but I'll give you the page number. Okay, right here. So I'm actually looking at page 1561. So I was off. So these are all the reserved words of C++ language. This is page 1561. So if you want to see what exactly C++ entails, so these words have a special meaning. Notice that all of these reserved words are there lowercase. None of them are uppercase. You'll find many of these reserved words in Java or C# as well. So there's a reserved word friend. So this particular word has a special meaning in C++. For is a reserved word. Case and catch and char and class, all these have special meaning in C++. So these words cannot be used for variable declaration. I cannot say friend equals to 25. We cannot do that because it has a special meaning. Got it? So these are the only reserved words in the entire language. That's it, just less than a page. So these are the only words, and you can write a program for a spaceship. You can write a program for game design. You can write a program to create new languages, new operating systems. web development. These are the only reserved words in C++. If you go back in C language, there were only 32 reserved words. So imagine if I memorize all of these, do you think I become a good developer? If I memorize the entire English dictionary, do you think I can write like a good poet or author? Probably not, because these are only the basic building blocks. What do you do with these building blocks? That comes with your skills of solving a problem. So, but this is on page 1561. Okay, so the variable is, you declare a variable, we call it an identifier. There are certain rules of declaring a variable. So you can use a character in a variable, such as n. You can use a number, such as 2, or you can use underscore. So this is a valid variable name, n underscore 2. So a character is legal, underscore is legal, and number is legal. These are the three things which are legal. None of the other special characters are allowed, such as dollar signs or plus symbol or any one of those when you're declaring a variable. So if you want to declare this variable as integer, so you're saying n underscore 2 is an integer. So when you declare it, you also want to initialize it. Initialize means you want to say, make sure it has a 0 value when I'm ready to use it. What it means is when you declare your variable in the RAM, it actually has a space assigned to it, n underscore 2, and this I'm placing 0, and I'm removing all the garbage from that location. Because from the previous processing, there might be some garbage. So when you initialize it, you say equals to 0 for integers. So this is one way to initialize it. The second way, which I'm recommending here, if you look at in the green, so I'm saying int num equals to int parenthesis open and close. Now this time, the C++ compiler is going to do the initialization automatically for you. So this is the recommended way to initialize, although that's perfectly legal as well. You want to declare your double. This is the name of your variable, and this is how you want to initialize it. Behind the scene, it's going to initialize to 0.0. So this means basically 0.0. So that's how you want to initialize your variable. So for project 2 and all the other projects, you must initialize your variables. Now sometimes when you forget, compiler might give you a warning. Sometimes it might give you a runtime error. So you're running the program, suddenly program will crash because you did not initialize your variables, because it found something illegal, found something which didn't make any sense, and it might crash the program. This is how you want to initialize your character. Initialize your Boolean variable. Boolean is basically true and false, true or false. And this is how you want to initialize your string variables. We'll talk about string in more detail in this chapter. So C++ and Java and C#, these languages are case sensitive, which means uppercase number is different from lowercase number. Many of the other languages are not case sensitive, but these languages are very highly case sensitive. So when you declare, it is recommended all the variables you declare in C++, they are lowercase. However, when you have a variable much longer in, such as like this, you say rate per hour. So this is the name of the variable. This kind of variable name is called camelback. Camelback. It has two humps because whenever you have a new word, you start with the uppercase letter. You start with the lowercase letter, but in the middle you have these uppercase letters. You can also declare this variable like this: rate underscore per underscore hour. So some developers, they prefer this style of declaration. Some prefer this style of declaration. There are some other standards as well. I personally like this standard. It's easier to read, and I don't have to type special underscore character. But either one of those are legal. Some, you might find people start with their variable names with underscore. They might say rate, underscore rate, like this. So that's legal. You can use underscore as a first character. However, you cannot use this as a variable name. What's wrong with this one? Because the variable name must start with the character, cannot start with the number. You're right. So if I declare my variable like this, that will be illegal in Java and C# as well. So this is illegal. So it's going to tell you in the next slide what are the good techniques of using variables. So this is illegal. This is illegal. Employee salary. Why this is illegal? Cannot have space. You can only have one special character, which is underscore. None of the other special characters are allowed in these languages. This is illegal because of exclamation mark. This is illegal because the compiler is going to think these are two different variables. That's not our intention. Our intention was just to have one variable, but this is actually confusing. Although I can use the plus to add two different variables, but here when you declare a variable cannot have a special character plus. And this is also illegal because it's starting with the underscore. Let me ask you this. Is this a legal variable? Is this a legal variable? No. Actually, if I run, it's going to run successfully. It's not going to cause me any problems, but it's not a good practice. Absolutely wrong. We should not do it because we have the same name. Function has the same name. Main is the function we use. So it's not a good practice. It's a poor practice. There are a lot of things are legal. Instead of California, we should not be doing it. And you know what I'm talking about. So, so how about this one? Is this a legal name? Technically, this is also legal, and it's going to let you use it. But again, if you have no friends in your life, that's what you end up doing. You have no conversation with people with months. That's what happens to you. You start doing these things, and you think you're smarter. Don't do these kind of things. It's going to drive you crazy, drive your project crazy, and the company is going to lose a lot of money. Don't do these things. I've seen people declaring variables like this, 2 underscores. Variables they must be descriptive. They must tell you 6 years from now, 10 years from now, what is the purpose of their variable. Like rate per hour, it's descriptive enough, but if I say R, it doesn't tell me anything. What exactly R means? Doesn't tell me an individual character, the purpose of the individual character. So some of the legal variables are shown on the top, and illegal variables are shown right here. So contains white spaces. I recommend highly you are generous with your white spaces. You are generous with indentation. Use them extensively. So especially when you're learning. So I love white spaces. So when you have line of code, add additional extra 1 or 2 lines just in case in the future you want to add more instructions in between. So they're data types. I have a slide on our canvas. This is what the slide looks like. And let me spend the next 5 to 10 minutes on this slide. So this slide shows all the data types available in C++. So we have simple data types, structured data type, address data type, and under simple data types, we'll pick about 4 of them. Under address data type, we'll use the references later, and pointers we use in CS12. In structured data type, we'll be using arrays, I think Chapter 8, data structures in Chapter 9, classes in Chapter 10. So there's a chapter assigned to this particular concept here. There's a chapter for data structure. There's a chapter for arrays. So we'll be discussing these structured in the future. We'll be discussing references probably 2-3 weeks from now. After the first exam, we'll start using references. We'll not be discussing pointers. That's something we discuss in CS12 and CS22. However, let's focus over here on this side, the simple data types. And as you can see from my whiteboard here, I want to stick these 4 top data types, and I'm going to explain why. So you have signed integers or unsigned integers. with a sign or no sign, like plus minus or no plus minus. You have a short integer and long integer. So there are three different types. In Java, they also have byte. So they have byte, short, integer, long integer. In C++, they have short integer, regular integer, long integer. Short integer takes 2 bytes of storage. Regular integer takes 4 bytes of storage. Long integer takes about 8 bytes of storage. Now, for our purposes, and by the way, whenever you're using different data types, even between short and integer, you have to do conversion. Because the compiler, many times, it does the implicit conversion for you. So let's say you use integer here, but short integer somewhere else. So, but there are 2 different data types. You have to convert them into the same data type in order to perform calculations. Now, sometimes you say, well, I didn't do it, and I still got the results. That's right, because the compiler did the work for you in the background. It's called implicit conversion. If you do not do the implicit conversion as a good practice, you have to explicitly convert from one data type to other data type. That's called explicit conversion. In order to avoid explicit conversion when we are learning the language, we are not going to use different integers. We are just going to stick to one integers. If you want to do explicit conversion, so there's a keyword called static underscore cast, what type of conversion you want to do, and the type of variable. So this is how you can do the conversion every time. Why do I have to write all this code to confuse me when I'm learning how to learn the simple building blocks? Once I feel comfortable, probably in CS12, then I can worry about these issues. Right now, I want you to learn the basic building blocks, so we don't have to do the conversion every time. So if this salary is double, I'm telling, convert this double into integer, cast it, put it in a cast, then store in this variable. So all you have to do is for multiple data types. So to avoid that, I'm going to ask you just to stick with integers. Integers. We'll not be using shorts or long integers. You're okay with that? The characters, what do we use for characters for? Chars. Chars store how many characters? 1 character. So you can store 1 character, such as middle initial, such as yes or no, such as true or false, T or F. So single character. So chars will be used for single characters. They're simple data types. They are not complex data types. The Booleans store what? True or false. True or false. Booleans are very important variable data types. Very important. And we'll use extensively in our class, and you'll see in other languages. So Booleans are only true and false. So we'll stick to Boolean, integers, char from that data type. Then under floating, we have floats, doubles, and long doubles. The floats take 4 bytes, doubles take 8 bytes, and the long doubles take 10 bytes. Long doubles do not even work in our personal computers because the long doubles are very large in sizes. The doubles are good enough for us, and I'm going to prove it to you in a slide. So for our class sake, for sake of simplicity, we'll just stick with double. We'll not be using floats and long doubles. However, you will see some code in different chapters. They're using floats, then they're doing the conversion. If you feel comfortable, some of you are comfortable, you want to do that, that's okay. But for majority of us, we'll stick to doubles. So anywhere you feel that you need to declare a variable where you want to handle the data of fractions, decimal places, real numbers, then use double only. Okay? Any questions on this? So we are sticking with integers, chars, booleans, doubles. And that's how we can initialize them. Let the compiler do the initialization for us. So every time for project 2, you declare your variables, immediately initialize them. So you initialize them. In that way, you're clearing the garbage. And we'll talk about other data types later on. All right, let's go back to the same slide. So then it discusses in your book these, which I already talked about it. Now, if you're using integers, as I stated, it takes 4 bytes. And that's the minimum, minus 2 billion to plus 2 billion. That's the value it can store. So it's a large number. It's large enough for us. So you can store this much data into regular integer. If your data is much larger, then you can use double. And we'll see. And then it talks about what some examples of integers. It talks about what is a Boolean. Talks about what is a char. That's what a char. Char goes under single quotes. Talks about the ASCII code. And I think I showed you the ASCII chart last time. And then it moves on to the floating data type. Just want to spend a couple of minutes on this slide, if I can get your attention. Now, if you're using a float can store 3.4 plus minus 3.4, 10 to the power 38. Is there a large number? 38 zeros. So you have 9 zeros, 6 zeros in a million, 9 zeros in a billion, 12 zeros in a trillion. But this has a 38 zeros. So float is a pretty large number. Pretty large number. But look at the double. Double can store plus minus 1.7, 10 to the power 308. Is that a large number? For sake of camera, say it's a large number. So people on the web, you can see it. It's a large number. You will never, ever write a code in your lifetime with that greater number. It's 308 zeros. Now, if that's not true, I'm going to work for SpaceX or JPL. Sure. Then you can use long doubles, because long doubles do not even work on our computers. Long doubles is about plus minus 1.7, 10 to the power 3,000. 3,000 zeros. So if you're calculating the distances between galaxies and stars of those galaxies, then probably you need long doubles. So if you get to that level, then you don't have to listen to me. Then you can figure it out. But right now, we'll stick to double, because that's a large number. This is a very, very large number. No banks, no institutions, they use bigger number than this one. This is a very, very large, unless you're running a simulation. There's simulations, they actually figure it out, different kind of scenarios. They run these extreme values. Then it's possibility for simulations. But people who are developing these simulated programs, they are at the much, much higher level. So they can figure out how to switch from double to long double. Our computers cannot handle long doubles. They don't have the capacity or storage or compiler processing. So the maximum we can handle is the double. Okay? So these are very, very complex and large numbers. So our double has the precision about 15 decimal places. Float has a precision about 7 to 8 decimal places. Now, when I'm talking about precision, if you have a double, let's say double is 2.45612098113732, and on and on. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. This is the precision. It's going to give you the precision up to this point in double. Very high precision. In float, it's about half. In long double, it's more. So we don't have to worry about the precision. You say, well, I'm calculating my paycheck up to 15 decimal places. You don't have to worry about it. This is the maximum we use in personalized. Banks, they go about 6 to 8 decimal places. So banks, they need higher precision in the background. On your paycheck, on your statement, you only see 2 precisions, 2 decimal precisions. Okay? So maximum error significance, it shows you float is 6 to 7. Double is about 15 decimal places precision. And it gives you some examples how the doubles can be used, which we did in the first project. Then it talks about some arithmetic operators, plus, minus, multiplication, division, modulus, which gives you the remainder. We'll use all of them. Then also shows you how we can use them and what are the benefits. Arithmetic operations. By the way, when we say in math terms, equation, what is an equation? How do you define an equation? So it has an equal sign, and there are 2 expressions on each side. There's a left side, there's a right side. There's an equality in between. So equation basically is a collection of 2 expressions. We call them arithmetic expressions. So you have expression on the right side. Typically, whatever you calculate on the right side, you're trying to store on the left side. The results will be stored on the left side. And you can switch them around. So it basically talks about it that in computer science, you can actually have unary expression. Unary expression. So only one, you can have binary expression. So where you have two things, such as num equals to 25. That's an example of a regular equation. You can also do plus plus num. That's a unary unary variable, or variable which is going to produce something without even having a full equation. So we'll see how that is done in C++, Java, and C# as well. Then it talks about, which I want you to read, that this actually is confusing. This is more readable. So use your parentheses generously to make it more meaningful. Because some operators, such as multiplication and division, they have higher precedence than addition and subtraction. Then it gives you another example of that one, another example of that one. So I want you to read this stuff. It's just basic math. It's exploring here. Talks about implicit conversion versus explicit conversion, which I already have mentioned to you. And it shows you how the explicit conversion happens. If you have values like this, 7.8 plus 7.5, looks like these are double values or floating values, then these can be converted into integers by casting it. So we are trying to avoid that initially. Initially, we will try to keep it simple. Then talks about string. So what is a string, guys? Did we use the string in the first project? Did we, or we did? So string requires a string library. So you add the string library, and then you have whole set of string functions available to you. Now, what string is? String is a collection of characters. We call it array of characters. In C language, we did not have string. We had only chars. So how do you use chars to create addresses or full names? You just have a bunch of these characters, put them together in an array. So strings makes your programming easier. So if you want to declare first name, you can say string first name. And you can store the value of the string like this. You can say the first name is, so strings are stored in double quotes. On the other hand, the chars are stored in single quotes. So that's an example of a char, single quote, and your strings are in double quotes. Okay? So we will be using multiple functions of strings in our class, and we'll learn how to become comfortable with strings. We'll be using strings in the second project as well. There are some constants. What is a constant? Constant is something which does not change its value. It's fixed. So there are certain things that are fixed. For example, for execution of the program, you want to make your value of pi fixed. You want to make the name of your institution fixed. So it cannot be modified during the execution. So you declare it as a const. You use the word const, C-O-N-S-T, const. And the data type, is it double, is it string, is it char, whatever the data type is. And normally the convention is, it's like a standard we use in programming. The constants are uppercase, to differentiate them from variables. Variables, they can vary, they can go up and down, they can change. Constants cannot be changed. So if I declare this conversion to 2.54, during that execution of the system, I cannot change that to 2.6. It's fixed, it's constant. Okay? So we'll use constants, and you'll find them in many of the places in the textbook and online. They're uppercase, just to differentiate them. So we talked about variable, how the variables are used. A lot of these things are going to overlap with our discussion from the last. Talks about what is a single versus double, equal. How do you assign values? Shows an example here. Declare a variable of appropriate type. We know how to declare a variable. It's just basically going over some of the things we have talked about. This is how you can declare variables. When you're learning, I prefer that you do not declare multiple variables in one line. Some of you are comfortable. I prefer that you have each variable declared in a separate line and initialize each one of them. But some of you probably have been using programming for some time, so if you feel comfortable, that's okay. But for most of you, declare each variable separately and have a descriptive variable. Please do not say X or C or N or those kind of names. Give more descriptive variable. However, later on we'll talk about for loops and some of the loops. We just need some kind of increment variable just to increment. In that case, it should be okay. But when you're using the variable for something more descriptive, have a descriptive name. This is how we can get the values from the user. So when I run this statement, it's going to wait for the user prompt, and it's going to accept the value from the user. And it shows you an example here. Let me also talk about increment and decrement. So if I have a variable, looks like this, c equals to 1, and then I say c equals to c plus 1, what is the value of c after this line? 2, right? This line can be written as plus plus c as well, or c plus plus. This line can be written as one of these. So we had a C language. The developer, they added more content to it, object-oriented content. And they said it's an increment from C to C++. So that's how they came up with the name C++. So C++ means increment by 1, or plus plus C means increment by 1. This is called pre-increment. This is pre-increment. Pre-increment. This is post-increment. Pre versus post-increment. Now, in this particular case, C will be 2 here and C will be 2 here, regardless, in both of these cases. However, there's a small difference. If I think I did the same example here. So if you have x equals to 5, what is the value of y when I complete this statement, when I run the second statement? So what is the value of y when I go here? Help me, guys. So initially this is 5. So what will be the value of y when I get to this line? So value of y will be 6. Do you agree or disagree? So value of y will be 6 because we are saying pre-increment. Make this one 6 plus plus 6. Make it 6. And assign to y. So y will be 6 and x will be 6. Do you agree with that? However, on this side, in post-increment, x is 5. Notice that the y gets the value of x first, then x will be incremented. In this case, the value of y will be 5 and x will be 6 after I complete the second instruction. So there's a slight difference in pre-increment versus post-increment. And this can be applied to decrement also, minus minus x or x minus minus. So just be careful when you're learning these concepts. There's a difference between those two, increments and decrements. So it talks about that in your book as well, and shows the differences between those two. We used a cout. Here's an example of cout. We did that. We used a \t. Did we use \t last time for tabbing? So I'll show you how to use \t. You can use with cout \t. So you can add 8 spaces. You can use \a to create a beep, like a sound. \n for a new line. And there are other special, we call them escape characters. So these are shown here. Then it talks about include, number sign include statement. We talked about this one last time. So those are libraries we include. Today we'll include string library as well. So the purpose of the string library will be discussed, and this is how we can include it. And that's showing you how to include a string library. Talks about main function. I discussed that with you as well. Talks about creating a C++ program and how do we run it. There are two parts to it: the program itself and the preprocessor. The libraries are included in your program. Then the program you create is called source program. The program which is compiled into is called object program, from .cpp to .obj. And once the libraries are added, it becomes .exe, executable code. You don't have to worry about it. It does it for you automatically when you hit Control F5, when you run your code. Behind the scene, it does the conversion for you. If you have an error, it will tell you. So when you have an error, you double-click on the error message. It will take you in the vicinity of that error. That's where the error is, which I'm going to cause the error, and I'll show you how to fix that error. Okay, I think this is where I'm going to stop. And before I stop, I'm going to just do a very quick demo. Then I'll give the podium to, or the stage to Mello.